Welcome to a terrific Tuesday, everyone, and thank you for showing up for your learning. Let's get started with a quick lesson on how we multiply, divide, add, and subtract rational expressions like these. So, when we're looking at questions like these, they are indeed fractions, and it does help to review how we multiply, divide, add, and subtract just general fractions. So let's take a look at those rules for fractions. If I'm multiplying fractions, a over b multiplied by c over d, here I multiply, these are called numerators, these are called denominators. So I could even, at this point, say there's some restrictions on these fractions. A, B, C, and D are any numbers, but B and D cannot equal 0, because we can't have denominators of 0 on these fractions. So when I multiply these fractions, I do A times C on the top, all over B times D. Okay, and then if I'm dividing fractions, A over B divided by C over D. Here, again, B and D can't be 0. And then when I do this, it's the same thing as saying A over B multiplied by D over C. And now we see that C also can't be 0. So here are the numbers that can't be 0 here. B can't be 0, D can't be 0, and C can't be 0. So there's where I get my restrictions. Notice that top and bottom here both have to be non-zero when I'm dividing by a fraction, because it was a denominator here, and then I flipped it and multiplied, and it became the numerator became a denominator. And then here I would just do A times D over B times C, just like this. That's multiplying and dividing fractions. So just to review, and we'll review adding and subtracting fractions when we get to those types of questions in just a moment. So, when you're multiplying these rational expressions, first step, factor all the numerators and denominators, and then state all the restrictions that you can on the denominator. After you've done that, you're going to multiply the numerators and denominators one by one. So just like when we had a fraction, you multiply numerator times numerator, that's your new numerator, and then multiply denominator times denominator, and that's your new denominator. I remember that the denominator is on the bottom because I think of demons down underneath our feet. I actually don't spend a lot of time thinking about that. Let's move on. So, and then the last thing that we'll do is simplify and state restrictions. Let's try that with this rational expression. So I'd encourage you to copy this down and follow along. And I'm going to work on blank paper just like this because, well, you can see through to yesterday's work if you look closely. So the first thing that I'm going to do is factor all numerators and denominators. So the first thing that I see up here is I can have, I'm going to copy my fractions, and then here, x squared minus 2x minus 8. I'm looking for numbers that multiply to minus 8 and add to minus 2. So those numbers would be x minus 4 multiplied by x plus 2. And then over here, this one will factor as well. Numbers that multiply to negative 4 and add to negative 3. Again, my trick is if they multiply to a negative number, signs are opposite. One's positive, one's negative. The bigger one is negative because it adds to something negative. So this would be x minus 4 multiplied by x plus 1. All right. And now up here, I have trickier ones to factor. So I might do some scratch work on the side to factor these. So that scratch work might look like this. I might write them down over here, and I might say 2x squared plus x minus 6. Let's factor this guy. So first thing I notice is that I'm multiplying to a 2x squared. That must mean that I have some 2x term and some x term. And then I will have numbers here that multiply to negative 6. So again, I have opposite signs. Now these numbers don't add together to give me plus 1 because one of them is going to be multiplied by 2. And so I can kind of pre-imagine my FOIL here and then play and get the numbers. Now my method would be use quadratic formula most of the time because you're going to get numbers that are trickier. Here the numbers are not that tricky. Okay, so if I take 2 and I multiply it by some number, and then I take some number and multiply it by x. One of them is positive, one of them is negative. I want these numbers to multiply to -6. So let's play with that. Multiply to -6. Well, that could be 2 times -3, or -2 times 3, or 1 times -6, or -1 times 6. And there's really not any other ways to do it. So I don't have to play around with many options here to figure it out. Let's try these ones. If I take -2 and put it here, then that would give me -2 times 2 would be -4. And then I put 3 there, that would give me 3. So that would add to -1. So that doesn't work. Let's try 2x times -3. Okay, so let's take the 2x, put it there. That will give me 2 times 2, that would be 4, and then -3. There it is. -3 plus 2. Now, you'll see that this factors into that, and I just had to play with this list of numbers to find those. Okay. So I can put that in as this trinomial factored, 2x minus 3 multiplied by x plus 2. Now let's factor this one, 2x squared minus x minus 3. Write it out. 2x squared minus x minus 3. And let's move it down. Again, this is going to factor into a 2x multiplied by some x. The numbers here multiply to -3, and there's only two ways to do that. 1 times -3 or -1 times 3. And they have to add to -1. So I can see it right away. This is +1 and this is -3. Okay? Watch. When I FOIL this, there's my 2x squared. There's plus 2x. Here's minus 3x. Plus 2 minus 3 gives me the -1. And then here's the -3. So that's that one factored. So I do preach just use quadratic formula, but I also don't want you to do work where you don't have to do work.
That doesn't give the same answer.
Where?
The 2x subtract 3.
So here 2x times 1 gives me 2x, and -3 times x gives me -3x.
The one that we did up top. 2x subtract 3 and 2x plus 2.
Here, 2x
Yeah.
minus 3 times x plus 2.
It's supposed to give us 2x squared plus x minus 6.
Yeah.
But when I FOILed it, I got 2x squared subtract 4x plus 2.
Subtract 4x plus 2.
Because, so like, 2 times x is squared, and then 2 times -3 is -6x.
2 times -3?
2 times x is 2x.
Yeah. Well, 2 times -3 here, we get the -6. And then -3 times x gives us -3x. And 2x times 2 gives us 4x. So 4x minus 3x gives us x.
Wait, it matters where you put the...
Oh yeah, the 3 and the 2 have to go in the right spot relative to this 2 here. So here, 2x minus 3 times x plus 1. So I'm going to put that in over here. 2x minus 3 times x plus 1. All right, so now I have factored the numerators and the denominators completely. There's no more factoring that I can do there. So now I'm ready to go on to the next step. The next step is to state all the restrictions on the denominator. So let's go ahead and state all of our restrictions. So we're going to take a look through here and see what x cannot be, and style points for listing them smallest to largest. So we would say x is not equal to, the smallest thing x can't be is -2. X can't also be -1. And x can't be 4. And there's a complete list of the things x is not allowed to be. Any one of these numbers would make one of these factors in one of the denominators 0. We're not allowed to have a 0 as a denominator, so none of those values of x are permitted. Now we're ready to move on. We can now multiply the numerators and denominators. So I'm going to multiply this by this and this by this. So let's do that. Bring this down to another line, and I would have 2x minus 3 times x plus 2 times 2x minus 3 times x plus 1 all over x minus 4 times x plus 2 times x minus 4 times x plus 1. Now this is just a chain of multiplication that links all of these terms. Now we can go ahead and simplify and state our restrictions. So when we're simplifying here, actually we could have simplified at the previous step. Saves us from writing some stuff down. Anything I see on both the numerator and the denominator divides itself to make 1, so those can be canceled away. This x plus 1 cancels this x plus 1. This x plus 2 cancels this x plus 2. And then I have squares on top of squares. 2x minus 3 times 2x minus 3 over x minus 4 times x minus 4. So I could write this as 2x minus 3 squared over x minus 4 squared. And that would be about the simplest that I could write it, and then I would state the restrictions there. Now, I would prefer to do my canceling up here. It saves me some writing. And I just noticed that if things are on the bottom and if things are on the top, that I can cancel them, and then I can bring these together. Avery?
I just have a question about when you factor 2x squared minus x minus 3.
Yeah.
You did negative 3, 1, but those don't add together to negative 1.
So let's take a look at my work and see if it's correct. So I have 2x minus 3 times x plus 1. Okay, let's FOIL it. 2x times x is 2x squared. 2x times 1 is plus 2x. Negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. Now I collect my like terms. This is equal to 2x squared minus x minus 3.
Okay, so when you do that, how would you know that negative 3 and 1 would, like, because when you factor and you get those ones, like, they don't add together at the time, so how would you know that those would be the ones?
Oh, how did I know that that would be negative 1? I know that when I have something like, if it's just like x squared, then I'm just going to have x and x at the front here, and that's where I'm looking for two numbers that multiply to this and add to that.
Oh.
It's when a is 1.
Oh.
And when a is not 1, what I've been suggesting people do in other cases, when we had like an a that was 6, and there would be multiple ways to arrange the x coefficients inside the bracket, to just use quadratic formula and bring your stretch factor down.
Right.
And then you can factor your stretch factor, and it avoids all of the parlor tricks of I can factor these.
Okay.
But these are simple enough that I believe that you can factor them without recourse to the quadratic formula.
Okay, that's it. Thank you.
So there I play with the numbers and make them work.
Okay, thank you. If you see...
You moved your seat.
Yeah. If you see that it's going to be like 2x minus 3 squared before you do like all the like the steps you did, can you just write it like that, or do you want us to do it?
Like this?
No, like over up.
Over here?
No, down one.
Down here?
Like.
Oh, like can you skip this line?
Yeah.
Yeah, skip this line.
Okay.
I was just trying to show you, go through all these steps.
Okay.
Here, multiply numerators and denominators just means smash these numbers together.
Okay.
Yeah, so you can cancel up here and then just write and go straight to that line, no problem. Yeah, no problem. Okay, now let's take a look at one more. Simplify this one. So go ahead and work ahead on this one. I'm going to pause the video. You're going to try to simplify this one as best you can, and then we'll meet back up and see if you've gotten it correct. Everyone's going to have that question. So a lot of people are going to have similar questions, so let's do this one together. So you have struggled with it on your own. You have solved it or you have not, and now we will solve it together. Me, I'm quite confident I'm going to get this one. So I'm going to first factor all numerators and denominators. 4. Well, I could factor that as 2 times 2. Sure, let's factor it. And then x squared plus 7x plus 12. I want numbers that multiply to 12 and add to 7. And here it's just simply they just do that. It's not like these ones where we had a 2x that was changing that. So when I'm working through these, if I get stumped here, I'm going to make some little scratch notes beside, and I'm going to list all the possible ways that I can multiply to 12. 1 times 12. I also know that it's positive. Both numbers are positive because I have two positive signs there. 1 times 12, 2 times 6, 3 times 4, and those are all the possible ways to multiply to 12. Now I look through this list for numbers that add together to give 7, and I find them. List all your possible multiples. Don't list all the possible ways to add to 7 because that's an infinite number. There's a limited number of things that multiply to give you a certain number, and you can usually list them all. So here we know 3 times 4 works, so we have x plus 3. Oops, I'm using wrong color. Doesn't matter. Times x plus 4. All right, and then this is all multiplied by, well, here this does not factor like a trinomial. I only need common factoring. I notice 3 and x squared, and this has an x, so x is common to both, a single x, and 12 is divisible by 3. So I can factor out 3x, and then I would distribute that in to this bracket against two terms to recreate that. So 3x multiplied by x would give me back 3x squared, and then multiplied by 4. There we go. And then this is all divided by 2. Okay, so now we have been asked to state all restrictions on the denominator. We've just done all our factoring. Now let's state our restrictions on the denominator. So what is x not allowed to be here? X cannot be -3. It cannot be -4. Beautiful. All right, now let's do our canceling. Multiplying means multiply top times top over bottom times bottom. Now, this 2 cancels one of those 2's. This x plus 4 cancels that x plus 4. There's nothing for this 3x to cancel, but it does multiply that 2. And then this x plus 3 is all alone on the bottom. So I have this is equal to 6x. Success! Over x plus 3. And that's done. Final answer. Now,
How, like, I feel like a lot of us wouldn't have wrote 2 times 2.
What? Yeah, I was into it.
you wouldn't have factored 2, eh? You wouldn't have factored 4 into 2 times 2?
What if the number's 5?
Then it would be 5. Because 5 is prime. If it were 5, you say what it would be if it was 5. So then the 2 wouldn't cancel on the bottom, and you'd still have 5 there. And you would have 15x over 2. It just wouldn't factor.
Wouldn't you just factor do you have to do like the 2 times 2? Couldn't you just see that?
Yeah, you could just see as me. Yeah, yeah. I am making the what is invisible for some of you visible. Actually, I think all of you see 4 as 2 times 2 already. But I see all numbers broken down into their prime factors fairly quickly if I'm going to do work on them. Like I'm going to just be factoring them. Now, you don't have to do that. I just did that because I said, do you remember what I said? I said, factor all numerators and denominators. Can I factor 4? Sure, I can factor 4. But if it was 5, I can't factor 5. 5 is 5 times 1. 5 is prime. And so then I just do 2 times 3x. Notice that the way I do my work, it's very clear that this is, left over. I can cancel up here as well. I could cancel that and call that 2. Cancel that, call it 1. Sure. You can cancel there. You can cancel here. You do it the way you like. I like showing you different ways to the top of the mountain. Then you would have an unreduced fraction. Then you would be saying 8 over 4 instead of 2.
If you divided or 4 and 2 at the start, then you would have 2 and 1. So then where would the 1 go?
1 is always there. 1 is a cheeky 1. 1 is down here, right? This is 1 times x plus 3.
Oh,
Yeah, so that's and it's kind of mystifying to think that this thing that looks rather ugly is actually this function here, which is not that ugly looking. It's 6x divided by x plus 3. Fairly straightforward. Julia? No? Okay. That was just resting question hand? Yeah. Okay. All right, so now let's take a look at dividing. So we'll do this one together, and then you'll do this one on your own here. You're going to do this one on your own in just a second, but let's do this one together. So when I'm dividing, it's the same. but we need to notice restrictions on all denominators, even before we flip and multiply. So if this gives us restrictions, those restrictions are still in effect even after we flip and multiply. So first thing to do is factor all of our numerators and denominators. So let's do that. X squared plus 3x just factors with common factoring. So there's x times x plus 3, and then this is all divided by x minus 2, and then we say divided by x squared plus 4x plus 3. That's x plus 3 multiplied by x plus 1. All divided by numbers that multiply to -2 and add to -1. That's x minus 2 times x plus 1. Okay, so now that's fully factored. Now I state my restrictions on the domain. So x cannot be -1 or 2. Now let's keep going. We're going to flip and multiply. X times x plus 3. I'm going to move this up. Ask me.
I was just wondering, so when you have a division problem, do you say like what x can be before you or after, before you flip it?
Before and after you flip it. Because we can never permit a 0 as a denominator. We have an almost religious-like zeal about avoiding zeros in the denominator. It's not something we allow to happen. It would be like, like we don't get behind the wheel if we've been drinking. You know, it's just not something that's conceivable of doing. We just don't do those things. So I don't allow this to be 0, and then after I flip it, so you notice that I'm now flipping and multiplying. This is x plus 3 over x plus 1, okay? Even after I flip it, I'm now going to restate my restrictions. I see that x can't be -1. I already had that, but x also can't be -3. So I'm just going to add that to my list. And now I notice that I have not listed them in least to greatest, and I think, darn, next time I'll list them least to greatest. Okay, so now I've flipped, and now I'm ready to multiply. So multiplying, well, first let's cancel some factors. So this one cancels that one. This x plus 1 cancels that x plus 1. Okay, now, oh, and we have x minus 2, x minus 2. Those cancel as well. Ho ho! This is just equal to, what is it equal to? X. Yeah, so that's, this is now a line, y equals x, okay? But let's take a look at it. But x can't be -1, 2, or -3. So it would look like this. We would have a little open hole there, a little open hole there, and a little open hole here. These open holes tell us these are the values we don't permit. This is the point 2, 2. This is the point -1, -1. This is the point -3, -3. None of those are allowed in this function. The other values all just create a line y equals x. So this is y equals x with 3 twists. 3 spots where it can't be. Diego?
I'm just a little confused on how it went from like a 3 on the here wait. Can I just go up there?
Yeah, sure. Yeah. You want to point with my
yeah.
my blue pen?
Well, just kind of like, I don't know how these two kind of like flip there.
Oh, yeah, okay. So this was division, but then when we were dividing fractions, it's the same as flipping and multiplying. Yeah.
Okay.
So I flipped it. Yeah, and so our numerators became our denominators. But what that did was we had to then reimagine what the limitations on the function were, because we can't have a 0 down here, but we also can't have a 0 down here after it's been flipped. So like I was saying back here, if we're dividing fractions, boop, 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 that these would be our non-zero numbers. Those are the numbers that can't be 0 when you're dividing. Rachel.
Why did the first one flip?
Which one flipped?
Like x plus 3.
That didn't flip.
Yeah, why didn't it though?
Oh, because when you flip the divisor. You flip the one you're dividing by. So this is like 6 divided by 2 is the same thing as flipping 2 into 1/2 and saying 6 multiplied by 1/2.
Okay.
but it's not 1/6 multiplied by 1/2 because that would be 1/12. No, we want the answer to be 3. We want half of 3. Sorry, half of 6. So you flip the divisor when you're dividing fractions. You don't flip both.
Okay.
Michaela?
When we take x squared plus 3x into x and then in brackets x plus 3.
Yeah.
What is the other x though? Because like it's gonna be like times 1x out of x squared, but where's the x go from 3?
From the 3x? Well, we would recreate that line with the distributive property. So this x multiplies x, and then it multiplies 3. And that recreates x squared plus 3x. Any more questions? Let's pause the video and work on the next problem. All right, let's take a look. So here we go. We have 3y on top. We have no y's anywhere else in the problem, so that's certainly not going to cancel away. Divided by 2x plus 10 over x squared minus 25. And this is, 4x minus 20. So my first step is factor. And so I factor here with common factoring, factor out the 2. That gives me x plus 5. 2 times x plus 5 gives me this one. 3y doesn't factor, it's just 3y. And then 4x minus 20 is 4 times x minus 5. I notice that both these numbers are divisible by 4. X squared minus 25 is a difference of squares, and difference of squares always factor this way. So write all that down. Now, state your limitations. X is not equal to negative 5 or 5. I have 5 here and 5 here that it's not allowed to be, and negative 5 there. After I flip, I do not acquire any new restrictions on the domain. So I can just go ahead and multiply. When I'm multiplying these, I can cancel factors. X plus 5 cancels the x plus 5. The x minus 5 cancels the x minus 5. And I'm left with uncanceled on the top, 3y. And I'm left with on the bottom 4 multiplied by 2, which is 8. Here I thought I was showing my human side by saying, oh, I made a mistake for a brief moment. And then I had to scratch out my 6 and write that as an 8. So sometimes I make mistakes also. And then that can confuse you. But don't be confused. Just know that I too sometimes make mistakes. Okay. Do you have questions about this one? So the textbook questions that you can use for practice are here. Page 94, numbers 1 to 9. But know that we are skipping for now adding and subtracting rationals. We will do this tomorrow. And we will start with something new right now, which are transformations of functions. So if you're someone who is sitting there saying, I still don't get this, that's why I'm still here, ready to talk to you. I have already said to some of you, I'm not answering that question right now because we're going to start now the next thing. So let's take a look at those. And bye for now. Definitely find me with your questions.